Okay, I had a problem pulled up out of your homework from 6.1, and I don't know what happened to it. So let me pull it up again. Let's see. There, somebody left. Who left? They came back in. Okay, that's fine. Don't talk to me. 6.1, and I had a problem pulled up and I lost it, so let me find it. There it is. So this one says, find the inverse of the function. And this is a test question. This is what I told you would be, I would test you on this type of, from 6.1, this is the type question I would ask you. So f of x is equal to 1 minus 3x over 4x. And the first thing you want to do is rewrite with y. And now switch all the x's and y's. So this will be x is equal to 1 minus 3y over 4y. Now I'm going to get rid of the, I'm not even worried about solving yet. I've got to get rid of this fraction. So I'm going to multiply both sides by 4y. And that's going to give me 4y times x is equal to 1 minus 3y. Now I'm going to take this x and move it over here and bring this y over here. And that's going to give me that's times, sorry. I'm going to divide by x. Well, bring the 3y over. That might help. Yeah. So that'd be 4y times x minus the plus 3y is equal to 1. And then I'm going to factor out y. Yeah. Factor out y. And that's going to give me 4x plus 3 is equal to 1. And divide by 4x plus 3. So y inverse is equal to 1 over 4x plus 3. And that is what you should be able to do for the test in 6.1. Now let's graph it. And we will graph this one. Since it is basic, we'll graph this one in blue. Okay, this is our original function. We'll graph that in blue. And we'll graph the inverse in pink. And when we do that, they should be symmetrical around the oblique asymptote. So let's go to our handy-dandy calculator. Y is equal. Oh, it's already blue and pink. Good. So I'm going to put parentheses 1 minus 3x close parentheses, divided by parentheses 4x. And then the second one in pink is 1 over 1 divided by parentheses 4x plus 3. And I'm going to do the y is equal to x. That's the oblique asymptote. I'm going to do that in dashed color. And I'm going to do it in a real, like, yellow. If I got yellow on here, yeah. And I'm going to change this to a dash. There we go. And graph. Okay, that doesn't look right. That doesn't look right at all. Make sure I typed everything in right. Let me zoom back. Sometimes you have to zoom out to look and see what you got. No, something's not right. Let me check. 1 minus 3x over 4x. And then 1 divided by 4x plus 3. And it's not even graphing the x. Why isn't it graphing the x? Damn Russians. Something's not right. Zoom, stat, or standard. Okay, there we go. Did it that time. Well, it's not symmetrical around the, well, it's symmetrical, okay, because it's a fraction. Let me do negative x. Y is equal to negative x because it's a fraction, because it's a rational. Okay, well, just take that one out. Y is equal to clear. And you can see that they are the opposites of each other, but not much. You can't tell very much. If you did a trace, you would be able to. So if you did trace, and on the first one, you did 0, let's see. Okay, there's 1.06, and negative 0.51. So I'm going to write that down right here. Could you mute your mic, Mr. Cash? I'd appreciate it.
Sorry about that.
That's all right. So I'm going to write down an X and a Y for the blue. And that's 1.06, comma, negative 0.51. Okay, now we're going to go to the pink. And let's see if we get a negative 0.51 for X. Let's see if we get 1.06 for Y. So negative 0.51. Well, it's not there. It's in between. There's negative 0.6. And we get a 1.7. So you can see that they are flipped. I can't get any closer. Let me see if I can zoom in and see if that'll help. See if I can get it a little bit closer. All right, now let's do negative 0.51. See if we can get a. There it is. Negative 0.51. Well, that's, oh, it's not on trace. I'm sorry. It's not on trace. There we go. Let's see if there's negative 0.56 and we get 1.37. Negative 0.53. See, we're getting close to that. And that's close you're going to get. We could zoom in one more time. Let's zoom in one more time. And this is the stuff you should be able to do. So now I'm going to hit trace. And let's see if we can get close to negative 0.51. Negative, there it is. Well, it's not exact, but as you can tell from the graph that the X and Y has flipped. So they are inverses of each other, 1.04, 1.05. Okay, so right here on the function, we picked a point, and that point was 1.06 and negative 0.51. To check the graph to see if this is the inverse, it should be reversed. So we should look at X is equal to negative 0.51. We did, and we came up with 1.05, which is very close to 1.06. And of course, you can tell that they are inverses of each other. That is what I'm going to test you on in 6.1. So if you understand what I'm doing here with the algebraically finding the inverse and graphically looking at the inverse, let me zoom standard. If you understand and how to graph that, then we're good. Okay? So that's 6.1. Anybody got a question on 6.1? All right, you do that one. That way, at least you'll have 2 problems in your homework done. I'll write it down while y'all are doing it. Ooh, how many did we pick up? Let's see how many we pick up. We picked up 2. We got 7 today. Boy, y'all suck. The rest of the class sucks. F of X is equal to 5x cubed minus 2. 5x cubed minus 2. Give y'all a minute to do that. Oh, wait. Okay. So we'll color this one blue because it is the function. So we'll just color that blue. So y is equal to 5x cubed minus 2. X is equal to 5y cubed minus 2. X plus 2 is equal to 5y cubed divided by 5. Y is equal to the cube root of x plus 2 over 5. And we'll go ahead and call that y inverse. And that should be the pink. So now we take our handy dandy calculator. And y is equal to clear. And that's going to be 5x cubed minus 2. 5x cubed minus 2. Oh. Delete. 5x cubed minus 2. And then the next one is the cube root. So I'm just going to raise everything to the 1/3 power. So parentheses, x plus 2. Well, I might have to put it in double parentheses. Oops. Double parentheses. It's just something I'm doing because your calculator might have a fit if you don't put it in. Oh, really? I'm about ready to quit. There. All right, x plus 2, close parentheses, divided by 5, close parentheses, and then raised to the 1/3 power. That's the same thing as taking the cube root of x squared plus 5. Graph, and that looks perfect. And this one we can actually put the yellow X in there, and you can actually see the symmetry. So let's pick a point. I'm going to hit trace. There's a good point right there. So for the blue, I'm picking 0, -2. So therefore, for the pink, when I go to x is equal to -2, I should hit 0. So let's look and see. There it is. So let's go to x is equal to -2. It's still on trace. Yep. Well, y'all see, there's the x-intercept. Now we're going to check it. Second trace, 0. And I'm going to check this one right here, left bound and right bound. And my guess is right in there. And -2, 0. So it does check with the points or the graph, and it does check with the algebra. So you have just found the inverse of each other. Now that's 2 good test questions for a couple of people that came in late. There's the first one I did. Find the inverse of this function. And we found the inverse, graphed it, and we picked a point. And this is the point we picked. And then we reversed it and checked it on the trace function, and it did check to be within 1,000th or 10,000th of the point we picked right here. Okay, so I'm gonna give you a second to write that down. Just write that down and find the inverse. And then the second question we did was this question. So there's the 2 that we did. And I will lift this up now. And that's how we did that one, because I saw a couple of people come in. And here is the graph of that function. And we checked, and we actually, when we graphed 5x cubed minus 3 and did a trace, the trace started on 0, -2, and since those are two whole numbers, we decided to pick 0 and -2. So then we jumped on the pink line and reversed it and went and tried to find -2 and 0, and it hit right on it. -2 and 0 right there. So it not only checked algebraically, but it also checked graphically. And those are two good test questions that come out of 6.1. Those are the type questions I will ask you on the test. Now let's go to 6.2. We started it the other day, so let's look at it and see if I can find it. There we go. And I think we actually got to y is equal to 2x. Y'all help me out. Did we actually get there? Somebody? Hello? Okay, nobody's going to say anything? Okay, that's fine. We'll just go all the way through 2.2 then. Nobody's going to say anything. I guess we covered all of it, didn't we? Nobody's going to say anything. Going once?
I think we did get there.
How far did we go? Okay.
The last problem I have written down is the one where it's 25 to the x power equals 125.
Okay, thank you. I mean, that didn't take a lot of effort. Thank you, Mr. Cash. I don't know why I didn't have 6 or 7 people saying that at the same time, but who knows? Okay, so I'm looking to see if there's anything. Let's go ahead and look at the interest. Go ahead and write that down because you're going to see that on a standardized test as well as a regular test. Compound interest is, as you see, P, which is the principal, times 1 plus R over N raised to the NT power. A is equal to P times 1 plus R over N raised to the NT power. P is the principal. That's the dollars that you put in. So if you put in $500 in a savings account, your P is $500. R is the rate that they give you at the bank, the interest rate. Interest rate. And it's always as a decimal. So 6% would be 0.06. N is the number of times it's compounded. Compounded is another word for calculated. Okay. So if it's 4 times a year, that's quarterly. If it's 2 times a year, that's semi-annual. If it's 12, that's monthly. And of course, one time a year is annually. And then T is the time always, and I'm putting this in red, that means something. Always in what? Years. So if I say to you, well, I'm going to do, hold on a second, I'm trying to adjust my camera. If I say to you 6 months, 6 months is equal to 0.5 years. Okay, so you need to remember that. T is always in years. So if I say 3 months, well, that's 0.25. T is equal to 0.25. And basically, you got to learn how to calculate it. And the only reason I'm showing you this part of the slides is because standardized tests usually has this on their test. So let's go ahead and do whatever they have for us to do. There we go. So I want you to write that one down as a test question and as a standardized test question. That is a question I would ask. So write it down. And then I want you to plug and chug and see if you can crank it through your calculator. Don't be surprised if you can't, because a lot of people, they don't twirl their calculator around their finger like a basketball, like some people do. So I'll give y'all another minute to write that down and see if you can calculate it.
You have a work email.
Okay, so here we go. I'm going to draw it out. And instead of having to write everything over, I'm just going to do this. And I'm going to say A is equal to 1,000, 1 plus 0.015 over 4 multiplied by the 4 times 10 power. Now, you shouldn't have to write anything down after that, because you should take your calculator and you should be able to type it in from that. So let's see how we do this. Watch. So first of all, get out of this. All right, so I'm going to work your way inside out because that's the way you would do with fractions, decimals, and percents. In other words, please excuse my dear Aunt Sally, you do what's in the parentheses first, then you do the exponent, then you do multiplication. Please excuse my. So I'm going to work on the inside of the parentheses first. 0.015 divided by 4 plus 1. And inside the parentheses, I get 1.00375. I'm going to raise that, and 4 times 10, I'm not going to punch that in the calculator because I think everybody knows what 4 times 10 is. That's to the 40th power. And then multiply that by 1,000. So at the end of 4 years, I'm sorry, at the end of 10 years, I think it said 10 years, didn't it? I think so. At the end of 10 years, you will have 1161.51 in the bank, and you hadn't even touched it. Okay, that's the way interest works. So that is a test question on compound interest. Anybody got a question on that one? Okay, nobody's going to say anything, so I'm assuming.
I have a question.
Okay, what's your question?
At the end of that question on the PowerPoint, it says how much interest is made. How would you go about finding that? Since
What did you put in? What did you put into the bank?
1,000. So is it talking about the money?
It's the money that's paid
Okay.
after you. In other words, to find the interest paid, and you know how to do it, you just don't think of it like this.
Okay.
Interest paid would be the money that you have at the end of 10 years minus the money that you put in.
Okay, that part of the question was confusing me.
It's confusing because you don't think about it like that. Now, if I asked you how much money did you make, you would be able to tell me.
Right.
Exactly. And it's just the way it's worded. So when you're talking about interest paid, think of this as how much money did you make at the end of 10 years? If you think of that as how much money did you make, then you know exactly what to do to get that answer.
All right, thank you.
The other people in the class, Miss Maxon, are going, she shouldn't be talking. She should be like us. You're not supposed to ask questions. Right, class?
But if you don't ask questions, you won't get answers.
How dare you, Miss Maxon? How dare you? You're not supposed to say that. You're supposed to sit and not say anything and not communicate. Right, class? See? That's the way you're supposed to do things.
Communication's bad, questions are bad.
Yeah, communication is bad. When you get in your job, that's why you're all going to be in a little closet office and nobody's going to talk to you because you don't communicate. Thank you, Miss Maxon, for talking. And Miss Davis, I appreciate you putting that in there too. Okay. Next is, I want to make sure there's nothing else. And you can also graph and make sure you see this. I mean, I just want you to see it, that you can actually graph what we just did. And instead of putting a T, you put an X. And that where you can look at anything. Let's do that. Let's put in y is equal to, and I'm going to clear everything. And that's going to be 1,000. 1,000 times parentheses 1 plus 0.015. I got to move it up. I'm sorry. 0.015 divided by 4, close parentheses, raised to the 4x power, and graph. And zoom standard. And zoom 0. There it is. Now I'm going to zoom back now so I can see where it's going. Zoom out. And let's zoom out one more time. There she is. Now, the good thing about these, you can go to second graph, which is table. And now you can do all you want. What about 4 years? 4 years, or 5 years, sorry. 5 years. 5 years, you would have $77 made, $78. What about 15 years? In 15 years, you'd have 1251.8. What about 20 years? In 20 years, you would have 1349. So it's good that you can graph that equation for T right here, 4T or NT, 4T, because that T is how many years you keep the money in the bank. So that would be a good test question. I would ask this test question on a test. I would say, given this formula, blah, 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 how many years would it take you to double your money? Well, you'd have to find 2,000. So you'd go to calculator. It might not even be on there because it's unrealistic. No, there it is. $2,000. Well, what's closer, 1961 or 2114? I believe 1961 is closer. You would have to leave that money in there for 45 to 50 years to get it to double. So that's a good question to ask on a test. I like that question. Now, the other type of compound interest is continuous interest. Pert. Write that down because you need to know it. Pert. Used to be a shampoo called Pert. Used to be in a green bottle. It's called Pert. Let's see if they still have a picture of it. There it is. Pert. Yeah, gum. $30. So that didn't used to look like that. It used to be in like a little, let's see. I was going to look and see if they had an old bottle. And it came from Prel. Prel used to be in a clear bottle and it used to be green, a clear green bottle. I was trying to find the retro bottles. Oh, well. Yeah, we're looking at shampoo bottles. I feel like looking at it. So that's what I want to do. It's not like y'all are being conversive in the class. So it's not a big deal. I bet y'all didn't even know that there was a shampoo called Pert. Did you?
No. I knew about it.
What'd you say, Miss Davis?
I said I knew about it.
You might be dating yourself, Miss Davis. Watch it. Miss Yarborough says, no, I didn't even know about it. I was looking for the old bottle of Prale. If you ever seen the old bottle of Prale, you would know what I'm talking about. It used to be a clear bottle, and it had the shampoo looked like goo because it was so thick.
It was almost like the sunscreen after stuff, with the aloe in it.
Uh-huh.
Is what it looked like.
Old Prale shampoo bottles. There it is. What it looked like. And that's what people wash their hair with. And then people say, well, why don't you add conditioner to it? And that's when they came up with Prale with conditioner called Pert. Yeah, there's the old Prale in the tube. I remember that too. So I remember this as a kid, so I don't know how old. And then you had the old Pert bottle. And the first Pert bottle looked like it was no, it's none of these. These are not the old ones. It's Friday. I can do stuff like this. I can have a free day if I want to. Well, I can't find the old Pert bottle because it wasn't any of these. But anyway, now you know the continuous interest formula. Pert. A is equal to P e to the RT. And this one, P is your principal. E is a constant in your calculator. Constant in calculator. And R is rate, usually as a decimal. And T is years. So let's look at the example they give us. There's the example. So this would be A is equal to 1,000 E to the 0.12015 times 10. There you go. And if you notice, these two questions are very similar. And I'm going to show you something, I'm going to show you something here in just a second. I hate when y'all write me text messages because I can't see them till 20 minutes after. Okay, Mr. Melota, you thought the Prale thing was interesting? That's pretty sad, Mr. Melota, but I appreciate you interacting with me. Thank you. That's a whole lot better than these people that are winged on a pickle. Okay, so let's type this in a calculator. Because unless you're Rain Man, You're not going to be able to do it with a calculator. So second quit. So we're going to take E. E is right here above the natural log key. So I'm going to do the E first. You don't have to, but that's what I'm going to do. Second natural log of 0.015 times 10. And that's going to give us 1.16, and you're going to multiply that by 1,000. So at the end of 10 years, if the bank decides to do continuous interest, you get 1161.83. So what's the difference in that and the difference in the previous problem? What's the difference in continuous interest and compound interest? Ooh, 32 cents. Then why would you use continuous? Less mathematics. You don't have to do as much math. Let's go ahead and type that into the calculator and graph it. Y is equal to 1,000 E, second E, to the 0.015 X, and graph it. And I'm going to zoom out just a little bit more. What do you notice about the two? I'm going to keep on zooming, and I'm going to keep on being quiet until somebody says something. What do you notice about the two?
They're both the same.
They're about equal. Yes, not exactly equal, but they're about equal. In other words, they're very, 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 very similar. In fact, you wouldn't be able to see it. Even if I zoomed out one more time, you still wouldn't be able to see the difference between the two. See? You still can't see it. There's just a minute difference between the two formulas. Okay? So, what have we learned today? We've learned compound interest, continuous interest, and Prel and Pert shampoos. That's what we've learned today. So tell your parents that you got your money's worth today, or whoever supports you in your endeavors to better improve yourself with academia classes. Tell them that you learned about Pert and Prel shampoos today. All right, that'll take us to the end of 6.2 basically. And that way we can move into 6.3 Monday. 6.3 Monday. Let me turn off the presentation and turn off the recorder. And let me